degree in hydrology from Metropolitan Autonomous University. I guess it's UAM, no?
Mhm.
He has a master's degree from UNAM, and he has a second master's degree from University of Arizona in Tucson. Uh, he has worked on several hydrogeology and surface hydrology projects. He has published more than 60 papers and 2 books about hydrogeology. So today he'll be talking about effects of the magnitude 7.1 earthquake of 19 September in springs and wells of Morelos state, Mexico. Over to you, Carlos.
Hello, good afternoon. First of all, thank you to the organizers for inviting me. I'm going to present you the results of a study that we performed at the Mexican Institute of Water Technology that we finished last year, that it was related to the effects of the 2017 earthquake that we had in Mexico City and some other parts of Mexico. Well, this information that I'm showing you here comes from the state government. It shows all the public infrastructure that was affected because of the earthquake. You can see that around 84% of all schools in the state had some kind of effect. Hydraulic infrastructure, especially wells, hospitals, around 223 medical units. One of the main problems that we also had in the state was the cultural infrastructure that was affected, especially the old churches that we have in the whole state, around 243. Highways, bridges, sports zones, and something that they didn't put here in this map, of course, were the springs. Okay. Well, sorry. Since Roman times, according to the literature, it is known that the earthquakes can cause a lot of great variety of hydrological responses. Pliny the Elder, the 2,000 years ago, describing the new flows that appear after the earthquakes. So examples of these hydrological responses are the disappearance of some springs, increase, decrease, or discharge in some streams, fluctuations on permanent changes in water levels in wells, fluctuations and changes also in the water quality in springs and wells, and of course a lot of changes in biodiversity that is new, but it has been reported by some colleagues from Italy. My God. Well, some of the effects in wells, we can mention the following, no? The water levels in wells can act as seismometers, like we have here in the basement, because they amplify the groundwater movements, particularly at some special kind of waves that are produced by the earthquakes. Fluctuations and permanent changes are classified as co-seismic, when they are present at the same time as the earthquake, aposeismic, that can be sometime after the earthquake. They include sharp increase or decrease in groundwater levels that can be followed by a recession and a stereotic effect. And it's not unusual that the earthquakes can cause some changes, hydrological changes, What is surprising is the amplitude at the great distances over which they can occur. For example, you have here in this photo a well that is found in China, where the groundwater level was increased about 50 to 60 meters after an earthquake that was almost 300,000 kilometers away. In the case of the state of Morelos, the 7.9 earthquake of the 19th of September had some effects on springs and wells. In the case of the wells, unfortunately, they didn't were reported, and we only knew them the effects by verbal communication after sometimes the earthquake. For example, the well in IMTA, the water level dropped about 6 meters 1 week after the earthquake. The Paseos well, this is the location of the earthquake, south of Morelos State. And Paseos well is around here. This is IMTA well. And the water level in Paseos well, the level rose about 6 to 8 meters. And later on, it was decreased after below his normal level, no? Y el Pedregal well, that is also in this area, the flow reduced around half. Oops. Sorry. The flow reduced around half of his capacity, no? Before this earthquake that we had in 19th of September, we have another big one in the offshore of Chiapas. This earthquake, that was M8.1, was recorded in some wells that are located in the state of Missouri in the USA. Groundwater level variation in this case was around 1 feet above and drops around 3 feet below, no? The wells, of course, are not located in the same place, and it is quite probably that some of them are located in some unconfined aquifers and some other are located in confined aquifers. And this is very surprising. Now, the same earthquake, 8.1 of the 7th of September, was recorded on a well that is located in Denmark, around 9,500 kilometers from the center of the earthquake. No? The effect of this earthquake, the lag time was around 38 minutes. But as you can see, the well recorded the earthquake in a quite long distance from Chiapas in this case. No? In the case of the springs, the hydrological responses include a decrease of the discharge, the appearance of new flows, changes in temperature, and there are several reported cases in the international literature. For example, in Napa, California, the earthquake of 2014 caused that new springs in the upper part of the basin that was estimated in a total volume of 1 million of cubic meters. Okay? In the case of Morelos, several springs were also affected, coming back again to the earthquake of the 19th of September. In this case, we observe flow decrease in Agua de Onda, La Malinche, Palo Bolero. Flow increase in some of them, como Las Estacas. Flow disappearance, San Ramón, Ojos de Agua, Cochichinola. Changes in colorations in Las Tortugas, turtles. And in some others, we observe no changes. Now, of course, there are small springs on the states, but according to the State Water Commission of Morelos, he asked us to make a diagnosis of these springs with the objective of characterize the sites, determine the current conditions, and evaluate the affectations in quantity and quality in order to recommend actions for their possible recovery. This is the study area. This is the epicenter of the earthquake and the locations of the springs that are located here in 3 different aquifers of the state. No? We make a well survey around each of the springs. We define the flow direction, and we compare with the old flow direction we have that was performed by Conagua. And we didn't find any big changes from this configuration. We also took some water samples and measure in situ parameters. And we tried also to collect information from previous studies. No? Several field sampling campaigns were carried out from starting on October and finishing in June of the last year. And we compared the results with some standards, both for human consumption, but also for some of these, the water of these wells is used for recreation. So that was the other standard that we compared. No? This is the list of the whole determination that we did in laboratories. And for example, you can see here the limit of sulfate. That is 400, and some of the wells, especially Agua de Onda, that is used for recreation, has very high values of sulfate. Also here, this is sulfate and this is sulfide. It's very high, the value of Agua de Onda. It was very interesting and very alarming for the authorities, because the Agua de Onda is a big recreational area, and it was closed after the earthquake. So they were trying to solve the problem in order to reopen it again for the public. The people think that these waters has good health effects, so they want to go there and try to swim and take some of them drink the water. No? We also make a classification of the whole waters. Some of them have sulfate carbonate, and some of them we found that are calcium bicarbonate or mixed with some other ion. No? What we also found at this spring that is very close that the IMTA site has the best water quality of all, very low mineral content. No? And some other has very high liminal contests like Las Tortugas. We also make some other classifications using the Piper diagram and compare with some other analyses that we did in previous studies. And as I mentioned, the Agua de Onda is a recreational area with several, ¿cómo se dice? Las albercas, several pools. So the authorities were very alarmed and tried to see if the water quality changed with the earthquake. So in this case particularly, we collect several analyses from previous studies and try to compare with the analysis that we did after the earthquake. What we found is basically we see some changes in the water quality that we can not say that the water changed after the earthquake. We think that these changes are more related to the changes of the analytical techniques during the whole year, no? And also because of we don't know if the analyses were really performed well, the water samples were taken in very good conditions. But in generally, we saw that the water quality of these particular springs hasn't changed with time. We also took some analysis in order to make a isotopic characterization using a membrane and some isolated cell. We plot all the information against the meteoric line, and we found in the case of Agua de Onda that this water were changing because of the sulfate reduction by some bacteria. We also, according to this graph that I'm showing you here, we also were able to define more or less the altitude using the altitude gradient that we have from an isotopic network that we have on the state. We were able to define the altitude more or less where the recharge was occurring. So from all of these wells and springs, we define the altitude according to the isotopic content. We also measure the spring discharge using different techniques. This is Agua de Onda. And try to collect also some information from previous studies. As you can see, this very porous table, there is no more information available. In fact, there is the first time that we have this kind of phenomena in the state. In 1985, we also have a big earthquake in Mexico. And according to some verbal communication from some colleagues, some springs were also affected during that time. But there is no information available, unfortunately. But what we saw here in this graph is that most of the discharge of the springs is going down, no? It's decreasing, alarming decreasing. All this information was put in some conceptual model. For example, this is in the case of the Cuautla-Yactepec aquifer, where Agua de Onda is located. There are 3 hydrological units, an unconfined upper aquifer, followed by an aquitard, and at the end, an confined aquifer on limestone rocks. No? And this is a summary of one of each of the springs. For example, in the case of Agua de Onda, flow decreases from 380 liters per second to 80. Same water quality, as I mentioned, using the diagrams. And after the water is used in the pools, water is flowing through agriculture. So the agriculturals were very severely affected. No? In the case of Las Tortugas, we saw the same flow. There is no previous data. There is a change of coloration in this case. In this case of Las Estacas, I put you some examples. We saw an increase from 6.8 to 7.2 cubic meters per second. And some others were the opposite, no? Cochichinola. After the earthquake, there was an immediate disappearance of 2 of the 3 springs. The third one decreased from 400 to 100 liters, and after another earthquake in April 2018, it completely disappeared. No? So the agricultural and spa users were severely affected. There are some of the conclusions, and of course the authority wanted to know if the problem have some form of being resolved. And what we know right now is that it's very difficult to know the temporally and affectation, since it really depends where the earthquake affected the local or the regional geology. That means that, for example, in the earthquake of 85, Palo Colero also decreased its flow volume, no? But they started to excavate very close to the spring, and they were able to recover the flow. But that means that the affectation was very local. But when you had a very regional or very deep affectation because of the earthquake, it's very difficult to solve that problem, no? However, try to understand the aquifer behavior in face of the earthquakes. It's very important for a country that is in a Aztec seismic area, like Mexico, that depends on a large extent of the groundwater for irrigation and the water consumption. Well, several recommendations were made according to each one of the springs, but I think that this general recommendation is one of the main keys. No? We need to instrument all the springs. There is no information available, so we need to have information and at least put it in some reports like this one that is available in order to see what was the water quality, the flow, previous to some other possible events. We recommend to measure the flow with a monthly basis and try to determine at least the field parameters and take water samples for physicochemical analysis and bacteriological at least every 6 months. These are some photos of the springs. Palo Bolero, main springs completely disappear. Secondary spring that is actually used to fill the pools. But right now, there is a new spring around 100 meters below this spring, below the Coatepec River, in the riverbed of the Coatepec River that is flowing here in a submerged way. No? This is Las Tortugas change in coloration after the earthquake. San Ramon before the earthquake and after the earthquake, completely dry. Cochichinola before April has some water in one of the springs, and water was pumping with this infrastructure, but after April, the same spring was completely dry. Aguedionda, this is before the earthquake. You can see how the water was flowing through this level. This is after the earthquake. The water was here. Okay, so they had to pump the water from here. This was around for 350 liters per second. They only were able to pump around 20 liters per second here. No? And finally, this is Las Estacas that it showed a completely different phenomenon, no? Increase from 6.8 to 7.2 cubic meters per second. That's it. Thank you very much.
Thank you, Carlos.
You're
Such a
welcome.
wonderful talk. The effect of an earthquake on wells and springs. So in this block, we had two very interesting talks: the health effect of fluoride and nitrate, and now we saw the how an earthquake affected the physical and chemical properties of wells and springs. So, Dr. Kornanodi, can you please come on stage and we can generate a discussion about both the topics. Audience, your questions are.
Related to the earthquake. It's really good, your presentation. Have you detected springs, new springs in the area and out of the area? And also, what about the rivers?
Well, that's a good point. There is a new experience in some other areas. I was talking in the morning with some guys that we are doing some research in the Puebla aquifer, and we found a spring close to the Ixtaccíhuatl volcano that it was dry, completely dry during the earthquake of 1985. And in the 2017, the spring started to flow again. No? So something very interesting. And we also, one of the authorities of one of the Jojutla, that is in the south part of the state, of Morelos state, also mentioned us that they had a spring that increases after the earthquake to more than 20%. It was around 80, after the earthquake, more than 100 liters per second. But right now it is decreasing to around 30 liters per second. No? So I think that the problem is that the authorities or the people, we doesn't mention anything about it. It's not registered anywhere. No? So it would be nice to have all this information together at the same time, no? After the earthquake.
And the rivers, what about the rivers?
About the rivers, well, the only river that we measured was the only one that it flows from Las Estacas, but the others that we didn't have any information about it. The objective, remember, of this project was just to try to investigate the effects of the springs that the local authority of the water mentioned that it has some effect, others not, no?
Yep. Hi, So I find this project very interesting because there is also a theory that an earthquake can change the properties of the conductivity of magmas. And in the case of Popocatépetl, we saw an increasing in the activity of the volcano. So I wonder if there is a mechanical model or some kind of explanation with, I don't know, geotechnical parameters or any measurements that could explain the mechanism of the change in the, water flow in the area.
One of the reference that I put in my presentation, he's working with that, linking the equations from soil mechanics to groundwater flow. So there is, I think there is a very good PhD thesis if you want to study that.
Just a couple of questions because I was wondering because it's quite common to show us this kind of diagrams with oxygen and hydrogen isotope analysis. But I'm wondering, in both cases, why not to make some analysis of nitrogen and sulfur for ether, for sulfate, and for nitrates? It's more important to determine the source. In Mexico City, for example, the limestone are rich in organic matter, so part of the nitrates came from the lower part of the column. So the question is why not to make both nitrogen and sulfur isotope analysis?
I'm sorry, I couldn't understand you.
It's so common that you show some tables with oxygen and hydrogen isotope analysis, but it's quite common. The question is why not to make some sulfur and nitrogen analysis? That is more important.
Some other isotopes analysis? Yeah, we don't have the, we did analysis of what we had in the IMTAP. So we didn't make some others because of the money. But of course, no. We can make some other analysis. It is open.
I mean, just to determine the source for this kind of materials.
Yep.
Yeah. Yes. And another question is, if you compare, for example, Las Estacas and Agua de Onda, one is thermal source, another is the normal spring. So it's valid to compare both kind of water analysis?
No, of course not. In fact, we didn't try to compare that. We just put it in a graph just to see what was the water quality. But to compare no, because in fact, we think that they have different, the groundwater that is flowing from each of the springs, both of those is different, no? One is very deep and probably is a regional flow system in the case of Las Estacas. And the other is more kind of an intermediate flow that is in the case of Agua de Onda, no?
I would like to ask you about the springs in Cuernavaca. Cañón de Lobos is dividing the basins, but there is some, there were some affectations in Cuernavaca as well as Cuautla. And the other question is about the basin of Mexico. If, for example, the main recharge is the Chichinautzin range, and there is a spring very important, El Túnel. I don't know if something happened with that, because this is in the side of Cuernavaca, and all your data are in Cuautla, the other metropolitan area.
Yes, what is funny is that as I mentioned, the study was performed to the local authority, the Comisión Estatal del Agua, and they, after the earthquake, they started to get some information from all the aquifers, from all the wells and all the springs from the state. And the only one that we reported the only one that we studied. So in the case of El Túnel or the other very big spring in Cuernavaca, that is Chapultepec, they were not affected at all. Okay.
Yes, this is a question for Dr. Karunanity. Yes, I heard this morning that in India there is no restriction, for example, for um, um, the well or to the well or where you make wells or logs or in order to control the water from the wells. So you mentioned in your talk what kind of control you have, for example, in order to have a well control in the content of the elements you said in your talk. How can you tell us about to control the elements, for example, sulfur or nitrates? I mean, this is in relation. This morning, I heard that there is no control. In India, you can make wells everywhere without a control. So how can you tell us about this situation?
Yes, sir. As a control for nitrate and fluoride is not possible, but one of the techniques we are adopted for managed aquifer recharge. That managed aquifer recharge is several types of managed aquifer recharge have, like percolation fund, check dam, some other for 12 or 13 types are under comes managed aquifer recharge. You once for RO system, RO system you are adapted for RO system is cost wise very high, but this for permanent solution, managed aquifer recharge for permanent solution of dilution of fluoride and nitrate.
Yeah, okay, but
Yes.
But there is, for example,
Yes.
I can mention in Mexico, for example, we have some normas. How do you say that? In standards, for example, for the quality of water
Yes.
in wells. Standards. So, yes, how can you compare the standards of the water and in the wells or have in this situation? Because
Yes.
it was really very interesting your
Yes, sir.
talk,
But compared to Mexico, but Indian standard is rock type is geological formation is very different. That is very hard rock, metamorphic rock terrains for mostly for zone 3 for Indian condition. Mostly for gneiss rock, entire my study area nearby my state Tamil Nadu, entire Tamil Nadu for the water system is very contaminated.
okay, thank
Let
you.
me answer. Yeah, we have two different type of standards with reference to water quality. We have ISI, Indian Standard Institute is there. So we have norms, it is comparable with that of WHO and US EPA. So we have our own norms. For example, in Mexico, the concentration of nitrate is 10 milligram per liter. But as per Indian standard, we have 45 milligram per liter. And fluoride, it comes around 1.5 milligram per liter. We have standards.
Okay,
Yeah.
yeah, thank you. Yeah, no, I know that you have to do so. Yeah, okay.
You want to answer also? Okay.
Sir, the problem is, so we cannot control the people to drill number of wells. So it will affect because they don't have water. Where they will go? If you don't allow to drill wells, where they will go? They cannot there is no alternate solution. So the best solution will be the linking of rivers. Now in the recent government, in the election manifesto, so they have mentioned that. So we are going to link North Indian rivers with the South Indian rivers. So in the rivers in the South India are seasonal rivers. So if rainfall is not there, there won't be any flow. But North Indian rivers are getting water from the Himalayan ice. So throughout the year, you can expect flow because of the ice melting. So once you connect the North Indian rivers with South Indian rivers, if there is a water flow in the river, all problem will be solved. We need not go for managed aquifer recharge. We need not bother about the quality, quantity, everything will be, even seawater intrusion. We need not bother about anything because rivers are dry. So that is why we are planning so many things. Once the rivers are connected, though it is a very old system, once you connect all the rivers with the perennial rivers, all problem will be solved. So hope this government will move towards that.
Okay.
Hope it will solve the problem.
Okay. Thank you. Yeah.
Thank you.
Yeah. Thank you very much.
It's a question, sir. So, sir, thank you for your very good, very informative lecture.
You're welcome.
And, I have one doubt. After earthquake, have you observed any changes in the flow path of surface water bodies in this region?
Surface water?
Was like stream, if any changes in the flow direction or path, deviation, have you observed the surface water bodies?
No, not at all.
Not. That's what because you mentioned that some of the wells after the earthquake completely dried. So in that case, what is the reason for disappearing of water? Diverted to some surface water bodies or some
the reason for disappearance of the springs, changes on the flow directions of the water. Some of the main channels where the water coming underground were closed because of the movement of the
plates,
layers inside the earth. So could it be different changes? No. Let me tell you that something. It was very strong earthquake. I worked around say 40-50 kilometers from the earthquake, and I remember when the earthquake started, we were working, we were out immediately. We went out from the offices, and we were just standing up on the field, on the gardens of the institute. We saw kind of a wave coming from on the earth.
Undulations.
We almost were going down, no? Most of us. No, it was very strong.
Sir, in India also, we are having one big problem. So because of this movement of plate, so this Indian plate is moving towards north and it is hitting the Eurasian plate. So this huge it is hitting the huge Eurasian plate. So Indian plate is going down with respect to Eurasian plate. It is not able to move further. So it is going like a worm. So there are a lot of undulations in the continental part. So what happens, the running water, river is eroding the uplifted areas and dumping the sediments into the dams, reservoirs. So the reservoirs are silted up now. So this is another problem because of the tectonic activity. India is this is another problem in India.
We have observed changes in the
River course is also happening.
Nowadays.
Interesting.
Yeah.
Thanks. Sorry to ask a lot, but it's just that here in Mexico we have a lot of problems because the fluoride and nitrogen content on the waters. Mexico occupies the 5th place on the geothermal resources. So it's quite common that our aquifers release fluoride from the rocks. The question for Dr. Karunandini. If you saw or notice some a particular concentration on the granites instead just the amphibolites or whatever, because here in Mexico the felsic backbars are enriched in fluoride and also in arsenic. So you found another signature?
Yes, sir. That for hornblende biotite gneiss, the mineral, the apatite, biotite, muscovite, this increase the constant for the fluoride mineral. The water, rock water interaction, the dilute the fluoride.
But just on the granitic rocks, not on the metamorphic rocks. Do you found some high concentration of fluorides on the granitic aquifers?
Granite.
Yeah.
Granite also.
Here it's quite common. I mean, if we found high values of nitrate, fluoride, also we found some high concentration of arsenic or whatever. No?
Kermogite.
Say again, please.
He's asking that if the rock type is granitic, like granite, are you having the fluoride concentration there also?
Yes, sir. Yes, sir.
But no arsenic or another kind of geochemical signatures? Just fluoride, high fluoride concentration, that is all?
Yeah, geochemical.
And do you do some same analysis on the minerals? Or do you suppose that the fluoride came from the muscovites and biotites? Or?
No, I'm not done any for thin section. Only for, we have done for physicochemical parameter, laboratory study only.
Yeah, great.
Yes.
Sir, all the rock types are having fluoride bearing minerals. For example, granite is having, even the metamorphic rocks, the gneissic rocks are also having fluoride bearing minerals. Even charnakite is also having the fluoride bearing minerals. So, igneous terrain, metamorphic terrain, both the rocks are having fluoride rich minerals, contributing fluoride to the fluoride ions to the groundwater. And of course, we have done some SEM analysis. So, we have prepared thin sections from the rocks and to identify the minerals, fluoride rich minerals. Yeah, we have done. But arsenic is concerned, we have arsenic problem only in the northeastern part of the area, particularly in Bengal. In Bengal area, we have arsenic.
Bengal is quite high.
And one more important thing is the climate. Climate is also another important parameter which affects, which increases or decreases the concentration of fluoride. So in India, the Rajasthan, so where the temperature is very high, so the concentration of fluoride is also very high in that area. So the temperature is more, then the fluoride concentration is also high. So the climatic condition is also affecting. Even the fluoride concentration is more than 8 in those areas. More than 8 milligram per liter.
That's quite high. Thanks so much, sir.
Thank you. Yeah, rock, intensity of weathering, so nature of weathering, all are controlling the concentration of fluoride.
My question is for the doctor. Here in Mexico, the interest in artificial or managed research is increasing. So I wanted to ask you, how developed is this area in India, the managed aquifer research?
First, you identify for where is the check dam construct, exit check dam. Go to the particular area you collected water sample, go to laboratory analyze, and also without check dam area, both area you collected water sample, go to analyze in the laboratory, the constant of fluoride you for nearby the check dam or other than check dam, you both are compare nearby check dam for the dilute the fluoride. The flow direction check dam is very high, you immediately based on weightage analyze for soil, drainage density, land use, land cover, based on you promote the artificial recharge structures for managed aquifer, like. Yes.
Okay, thank you.
Thank you.
Well, thank you so much. I would
just want to show you this. Last year we finished this book. You can download it from the IMTA webpage that is called the Managed Aquifer Recharge, a focus over Latin America. The rest has around 1,000 pages, and it has some, one of the chapters talks about recharging in India, okay? But it has several examples from Mexico and some other parts of the world. So you can download it directly from the webpage of the IMTA, or make contact with me and I can give you the address.
Well, I would like to request Engineer Alberto Arias to come on stage and give a small gift and certificate to Carlos Gutierrez on behalf of our society and alliance. Thank you so much, Alberto and Carlos. Well, that's the end of all 8 talks today. Tomorrow there will be no talks, so we'll be going to field work in the morning. So we have selected 25 participants and all the guests to go to field work. So all these 25 participants that we have selected, I would like to request them to come exactly at 8:45 to the parking area of Institute of Geology and bring your water bottle, sun protection lotion, and a cap, because we will be spending like from 9 o'clock in the morning up to 2 o'clock in the afternoon in the field. So there is vehicle there will be available in the parking area of Institute of Geology. So see you tomorrow at 8:45 in front of Institute of Geology. Thank you so much for attending today's conferences, and again we'll be meeting here in this hall on Friday.